Now let's tackle a 3D problem with cubes. This shows you how to handle volume ratio and connect them to surface area. Here's the problem. Two similar cubes have volume of 64 cm cube and 216 cm cube. If the surface area of the smaller cube is 96 cm square, find the surface area of the larger cube. Notice that this problem gives us volume but asks for surface area. This is a good example to show how our scaling relationship will work together. First, find the scale factor from volume. Our volume ratio equal to 216 divided by 64, which is 0.7/8. We know that the volume ratio equal to k cube, so we have k cube equal to 0.7/8. And therefore, k equal to 3/2. Our linear scale factor is 1.5. The larger cube is 1.5 larger in all linear dimensions. Now we need to connect this to our surface area. Remember that surface area is a 2D measurement, so it scales by k squared. The surface area ratio equal to k squared equal to 1.5 multiplied by 1.5 to give us 2.25. This means that the larger cube has 2.25 times the surface area of the smaller cube. Therefore, the surface area of the larger cube will be equal to 2.25 multiplied by 96 equals to 216 centimeters square. Let's move on to a new problem. Now we have two similar triangular prisms. They have surface area 150 centimeters square and 600 centimeters square. If the base area of the smaller prism is 20 centimeters square, find the scale factor. Find the base area of the larger prism, and C, find the volume ratio. Notice how this one problem asks for three different things. But don't worry, the key point is to find the scale factor. Once we can find the scale factor, all the parts can be answered. Let's start with what we know. We know the surface area. So the surface area ratio equal to 600 divided by 150 equal to 4. And since we know that surface area is a 2D dimension, the surface area equal to k squared, so k squared equal to 4, and therefore k equal to 2. Our scale factor is 2. This means that the larger prism is twice as big as the smaller prism in all linear dimensions. So for part B, we have to find the base area of the larger prism. Now we need the base area. The base of a prism is a flat surface. So base area is also a 2D dimension. That means the base area ratio equal to k squared equal to 2 squared equal to 4. The base area of the larger prism will be 4 multiplied by 20 to give us 80 centimeters square. And lastly, we have to find the volume. We need the volume ratio. The volume is a 3D measurement. So volume ratio equal to k cube equal to 2 to the power of 3 to give us 8. That means the larger prism has actually 8 times the volume of the smaller prism. Let's move on to a question on cones. Two similar cones have volumes in the ratio of 8 to 27. The smaller cone has a height of 4 cm and a surface area of 36 pi centimeters square. We have to find the height of the larger cone and B, the surface area of the larger cone. Notice that this problem starts with a volume ratio and asks us to find both a linear measurement and an area measurement. Let's see how they're connected. As what we mentioned, the first point is always to try to find the scale factor. In this case, we have the volume ratio, so we can write it as k cube equal to 27/8. And we should know that this would mean k equal to 3/2 equal to 1.5. Now we know that our scale factor is 1.5, meaning the larger cone is 1.5 larger than the smaller cone in all linear dimensions. We have to find the height of the larger cone. So height is a linear measurement, so the scale factor is k. The height of the larger cone will be k multiplied by 4, to give us 1.5 multiplied by 4 to give us 6 cm. Next, we have to find the surface area of the larger cone. Surface area is a 2D measurement, so it's cubed by k squared. So the surface area ratio will be k squared equal to 1.5 squared equal to 2.25. So the surface area of the larger cone will be 2.25 multiplied by 36 pi to give us 81 pi centimeter square.
Smash your maths exams. Download Learn Maths Today for real exam questions and achieve top marks.